Ruh-roh, Raggy. What's in the box? Well, some money. I may have gotten myself in trouble this time. Alrighty, let's have a look at what I got. Check it out. Alright, here we are up close and personal. Here's the nameplate, in case you were wondering. So, this machine here is an example of a so-called mini-mill. There's a pretty good community behind them, and they're great for hobbyists because they're pretty darn cheap. New one of these things bought today would cost, about $500, maybe $600. But of course, this is not a stock mini-mill. Stock, this thing would have had, these handles instead of steppers, because this thing has had a pretty nice kit applied to make it fully CNC. So we've got these. We've got one up here. They are Kaling technology, quite nice steppers. And we've got a few more mods as well, just to kind of round it out. So if you look here, these used to be lead screws. The old ones are sitting here. And yeah, these are ball screws now, which reduces the backlash quite a bit, so it's ideal for CNC work. So that's quite a nice upgrade. In addition to that, the drive has been upgraded from the original gear system to this belt drive system, and that does a couple things. First of all, it increases the spindle RPM, which is nice. Also, it reduces noise and also provides a bit of elastic buffer in case of problems at the workpiece, so that it doesn't break the gears or whatever. In theory, it'll break this thing and provide a little bit of elasticity to dampen those things. So that's nice. Let's see. So this thing used to be a click on type thing, like an old TV or whatever. You turn up this thing, it turns on a little switch and it activates the machine. Well, that broke. The knob works, you can change the speed, but it doesn't turn on automatically, so they replaced it with a switch. Not a big deal. Fuse holder's a bit, well, it's not long for the world, but anyways, this thing works fine. That's good. This gas cylinder here, to help this thing move up and down, well, it's not really attached down there, but apparently it's been like that for a while, so yeah, I think I might just leave it until I feel ambitious. It's kind of a hack job right now, but it works. Let's see, what else? Cables could do a little bit of redoing. They're a bit old. There's a split in some of them. No, that's supposed to be there. Ah, yes, here we go. There's a bit of a split there. But other than that, this thing is just fine. It's a bit rusty on the back here. It's a bit dirty. It needs a nice bit of TLC. The table needs to be adjusted a little bit. It has a bit of play in it. Needs to be adjusted, small things like that. Oh, by the way, it doesn't have wheels. This is just my floor jack that I was using to wheel this thing around. It weighs about 150 pounds, so not exactly the easiest thing to cart around. Anyways, let's have a look at the accoutrement. So, okay, so this is the box of stuff, the chuck, the various collets, different sizes. I can open it. Hello. Exciting YouTube footage right here. Okay. Collets, you put your stuff in there and it's all happy. Spare gas cylinder. Quite a stiff one. There we go. Let's see, what else? Of course, these are all the old parts that were, that used to be the manual control system. Probably won't ever use them, but there's certainly lots of useful bits for other projects. Power cord and parallel port, D25. This is the driver. We'll take a look inside of this in a second. But basically, we've got some drivers in here, power supply, and output for the spindle motor, output for the the flood lube system, which I don't have. I'll have to make one up. Power input, and then the 3 stepper drivers. This one's just a spare. There's actually no driver inside of it, but oh, there we go. Yeah, this connector hasn't been assembled. Anyways, and parallel port input. Now, to drive the whole thing from a software standpoint, get this out of the way. There's this machine here. It's an old P3 compact desk something or other, Desk Pro EN. Yeah. This thing is running Linux. I think 2.6.12 or 13 or something like that. You're running a slightly old version of the Linux CNC. So yeah, so for all these old CNC things, and you don't really need much to drive them. So what you're looking for is latency. So like if it takes a long time for the CPU to process like an interrupt or something like that, that can cause you to skip steps driving your CNC, because everything is bit banged out of this parallel port, not this one, this one. So you could have like a a really nice fast CPU, but if it can't react to interrupts and react to timing events correctly and quickly, then it's not gonna be ideal. So this is gonna be all I need. I'll probably upgrade Linux on there, stick a recent version of Ubuntu LTS or Debian or whatever, and that'll be good. Not that I really have to, but it's nice. Nice floppy drive here. Nice. It's actually got USB, so it's not that old, but anyways, Pentium 3, designed for Win 2K. No idea of the RAM, no idea of the disk, doesn't really matter. I'm going to make an image of it for backup purposes in case this explodes, and probably I'll mess with it later. And then I went and stopped by my local computer surplus place, bought this, you've seen these. It's nice, so you don't get problems with shavings or whatever getting inside of your keyboard, because this is nice and sealed. So that's good. I don't have a sealed mouse. I'm working on it. Let's see, what else? Oh yes, this is an IKEA table. I'm going to convert this into a CNC table. Well, CNC holder. CNC mill holder, English. So that'll be good. Now we'll sling the controllers and the computer underneath, and it should be a nicely self-contained unit. I plan on actually having a flood lube system, with a pump and a little tank of recirculating lube, and a nice little curtain around the entire thing to prevent leaks. But that will be at a different time, I suspect. I plan on actually starting with wood and not aluminum and other metals, because, well, I'm incompetent at this kind of stuff because I've never done it. So there you go. And I also need to get some bits for it, or not bits, well, whatever you want to call them, tools. I guess these are some of the parts for the original drive system. Yeah, I can imagine why you'd want to upgrade that. It doesn't look particularly awesome. So I guess this fit somewhere in there. Yeah, whatever. Not too interested in that anymore. Well, I couldn't help myself. Here's inside the driver box. So what we've got here is a pretty simple setup. We've got power input over here. Here's the power output. Here's the solid state relay to control both little plugs here. So I guess one side would be for the spindle, and the other side would be for the pump, the lube pump. Over here we've got this giant toroidal transformer going into bridge rectifier here, and going into a capacitor bank, smoothing capacitor bank. The caps are Capex on, not the best, but well, I'm sure they'll be alright for a while. Nice bus bar construction, altogether quite nice setup here. Here's the power for the fans. We've got the 3 stepper drivers. They're L297s. These chips here. These are H bridges with a big heatsink. Let's see, what else? Oh, here's an interface board, 4-axis PC interface driver. As you can see, the 4th axis is not currently hooked up, but there's certainly room in here to add it if I ever need it. So these boards themselves are for pminmo.com. That's pminmo.com, and you know they sell these little kits or I guess just blank PCBs or something. I haven't really looked into it. One thing I don't like too much about this setup is that the parts, and especially the heatsink, are all kind of loose. The only thing holding these heatsinks and their respective devices in place are the leads of the actual device. So if this thing is constantly vibrating because it's on the same table as the CNC, maybe it's a little loose, that could definitely break the pins. So I think what I'm going to do is I'm going to quickly fab up some sort of bracket or something to just hold these things in place. I can't figure out how to open this thing. These look like they've been pried a little bit. I wonder if the previous owners were also unable to open this darn thing. Well, I can't believe I just asked Google that. Ugh. Well, apparently I'm not that much of an idiot. Apparently these things have a CMOS controllable lock. So I guess these screws hold in a little lock here. So good thing I have a set of security screws or security bits. Alright, the screws are out. Let's see what this does. Still? Oh no. Alright, so you look at this and you say, okay, there's a little thing here, clearly you have to push that. And alright, here's the back. So which way would you say that this top comes off? I would say either you do this and you pull up and it hinges, that's one option, or you pull back and it comes off that way, because there's this front bezel in the way. No, you push this and you push that way, and the entire front bezel assembly comes off. Alright. You know that mug where it says like Midvale School for the Gifted? The door says pull and the guy's like pushing? Yeah, it reminds me of that. Except there's no genius here. Let's see if this works. Come on. For Pete's sake. I think I've gotten into Apple products easier than this.
Eventually.
Here we go. Alright, so it's got a 6.48 gigabyte drive in here. Yeah, some RAM, whatever. Pretty old stuff. But I'm curious to see what that lock assembly does actually. Maybe I can reuse it. Maybe it has like a solenoid or something. Who knows? Let's go see. It's as dusty as I thought it was going to be. But might as well. Yeah, at least once you're in, this thing appears fairly serviceable. See this PCA cage? Looks kind of like it'd be a pain in the butt, but no. You just pull it right out. And then you can add your PCI cards and plug it right back in. Nice. In case you were wondering what the parallel port card is, here you go. Not particularly interesting. Okay, so let's look in here. Very nice. It just pivots up. And this is almost very nice. It's pretty nice, I suppose. You have to unplug these. CMOS clear. Here's the optional lock thing. Yeah, I guess this is a bidirectional solenoid. A pin comes out and prevents you from opening it. Very nice. That doesn't need to be in here. I could certainly use that for something else. Nice. That can sit there for now. No, wait. That can sit there for now. Okay, so apparently 256 megs. Oh, sorry. Yeah, 256 megs. This one's a 128. I assume the other one's going to be the same. Oh no, it isn't the same. 1 second. Ah, this one's different. Oh, it's still 128. Okay, fine. Whew. Yeah. Back in 2001, 40 bucks got you 128 megs of PC 133. Yeah, good times. Not really. I just bought 8 gigs for, I think it was just the same amount of money. I've brought some reinforcements. Screen, mouse, G-parted live CD, Wi-Fi stick, so I can have internet because I have no wired things here, and Tony Stark's head upon which I can effect the download of the entire image of the disc for, you know, if it all decides to explode. Alright, let's do it. We're in good hands. Well, good thing I bought these 2 lac tables. Last time I went to IKEA. They're so freaking cheap. I think they were like 15 bucks. Anyways, I think what I'm going to do is take that table there and stack it on top of this table and kind of screw it, you know, together so that it doesn't move. And then I can have the machine sit on top of the top table and the electronics, which fits perfectly, by the way. All I have to do is put some screws in there, put some screws in there, and it's fine. It's crazy. Anyways, I put the electronics there, and I'll stack the computer under the other one, and we should be good to go. And then I can use the bottom table to house various, you know, the tools and, you know, various end mills that I'm going to have. It's going to be awesome. Well, I'm progressing in building the table. I've made some connections there, putting these braces here, Loctite on the threads, because I am worried about vibration. Since this is going to be sitting just below the machine on the same table, I expect there to be a decent amount of vibration, which brings me back to these heat sinks, which are not attached to anything. I was thinking of bracing things, like I said, but I have come up with a simpler solution. Place that across there. When I put the cover on, it presses just gently against these, and will hold them in place. So it shouldn't be a problem. It's not the most elegant solution because, of course, the pins of the device are acting as the other attachment point for this, which again is not ideal, but it'll certainly damp those vibrations quite nicely. That leaves these ones over here, which I think what I will do is just take my handy dandy hot glue gun, which is sitting over there, warming up, and just kind of goop all those things down. And, you know, kind of prevent that from happening. Gooped everything down on the base, so like over there, put a bunch of hot glue there, and I also gooped the actual device to this neighboring capacitor, so we have a pretty sturdy mount now, so these don't wiggle nearly as much as they used to. So I'm pretty happy with that. Nothing else on here seems to be capable of being broken loose by vibration. Yeah, famous last words. Oh wait, oh, there's a regulator in there. Goop time. I've added some thread locker to this nut here because I really don't want this thing vibrating loose. That would be bad. Everything else seems pretty good. I don't see lock washers in places, but nothing that will cause explosions, I think, if it comes loose. So I'll fix it if it breaks. So I've got various bits of this endeavor drying right now. So I turn my attention over to this, you know, motor here. You know, it just fits in there. Here's the Lovejoy coupling, you know, rubber shock absorbent. Anyways, I've decided that this thing needs a little help. I don't like it being all kind of grungy like this. Same with this motor up here. You know, the paint's coming off. So I think I'm going to take this off and mask off the area that's alright and just repaint it. Maybe a hot rod red or something like that. That'd be cool. Not doing so well. Also, I don't like these wires just hanging like this. I'll have to think of something. Okay, so I've cleaned off the old crappy paint. It just dissolved off with some acetone. I've cleaned everything off nicely with some alcohol. And now I'm just going to mask off the parts that I don't want to paint, namely the end bits, and just, you know, start painting. Parts have been masked. Now let's paint. I was having some problems with the belt drive not having enough tension, and there's this, I'm not sure what it was. I guess it used to hold a gear here. That's actually preventing me from sliding this plate backwards enough to create the tension in the belt, which is a problem. And I noticed that this plate has been drilled out, looks like by hand. So I think this was a modification done to install the kit. So I think I'm going to have to drill that out and get myself a bit more play in here. This is also a good place to just take the motor out and clean it up a little bit. I've already checked the brushes, they're actually perfect. Not much wear in them at all. Okay, here's the motor, separated out. Pretty standard stuff. Here's a little bracket, or whatever you want to call it. The paint on this thing has become all rubbery and it just peels right off, so I'm going to redo this. Looks like it's some sort of phenolic. And the motor should be easy to repaint. The casing of the motor is outside getting painted. In case you're wondering, here's what the rotor looks like. And there's the brush housing. It's the next evening. The painted parts have dried, and boy, they're looking a whole lot better. Very nice. Much better than that nasty old rubbery paint, that's for sure. So let's put this sucker back together to see if it'll still run. I don't think it will have any problems just because of some paint. Alrighty, here's the alpha release, as it were. I've gotten pretty far, I think. I've got a nice setup here. You might be able to hear the fans rattling in there. There's a wire in there that I need to fix pretty quick, because this thing doesn't usually sit upside down. Ooh, it's not happy with me. Anyways, I can control it. That all works. I can turn on the spindle, turn it back off again. Seems to work great. The only problem is this monitor seems to have some weird banding issues here. I'll see what I can do to fix that. It might actually be the graphics card. I'll have to test it with another monitor. But hey, you know, this isn't meant to be look pretty. This is meant to work, and that certainly seems to be the case. So let's shut her down, and I think it's good enough for today. It's about 1 AM right now. Here's a bit more detail about the keyboard area. So this thing can slide out like that. I need to do some cable management and all that once I've cinched down everything and settled on a design. The panel here can easily be removed for servicing, so I can undo those screws there, I can undo those there, and this panel will pop off like before. So of course it's upside down, which is why the fans are somewhat unhappy right now, because there's wires running into them. I didn't think of that. Fairly secure little bracing. Computer rack down here works pretty well. I'm thinking I might replace this thing with a slightly more powerful machine, maybe a whatchamacallit, thin client of some kind, because a lot of those have parallel ports and they have, you know, a somewhat faster processor, more RAM, and they're tiny, so I could like add it right here and screw it to the top there. So that might work, but for now, that's certainly doing the job. This little compact. Cool. Well, I'll end it here. Thanks for watching, and I'll do some follow-up videos as I learn how to use this thing, and hopefully show some stuff actually happening. I don't have any tools for it, unfortunately. All I have are, you know, these collets and that thing. So actually, these are my Dremel tools, and I certainly could use some of them for this mill. I mean, this could sort of do something, not very practical, but I do have, come on, let me adjust this light. I do have a mini end mill here, which is high-speed steel. It works pretty well. I use it to do some aluminum machining just by hand, so it's definitely got that. I could use that. It's got a similar end mill for wood. I tried this on metal, it doesn't really work. And this thing here, which I think is supposed to be used for tile or something like that, but it could certainly be used for like wood and things like that, so maybe I'll try that out. But my shipment of tools should be arriving in a couple of days anyways. Okay, that's it.